In this episode of Home in the Earth, we experiment with lightweight concrete fills. As per usual, my research into shotcrete started with YouTube. And you can find lots of stuff on YouTube. Best Aircrete ever, or lightweight cellular concrete is another name for it. Flowable fill, and all kinds of good stuff. You can get instructions for how to make these Aircrete bubble machines, and you'll see they'll do a lot of test samples and things like that. And one particular one that every now and then you'll see one of these. I don't know, maybe he's going to say that he loves it. I don't know. He's obsessed. I don't know. But there's lots of videos, tons of them. And back when I did this, it was in 2019. And so I was looking at a lot at Aircrete Harry. And so it would have been his videos about maybe 5 years ago that I was watching, where he used his wife's stove, wherever that is. Oh, this one here, I think was the last one I watched before I got going. But you can see in his, he's got videos showing how to make it, and he makes all these test samples. And he's got a gun too. Yeah, here's his foam generator. I changed his design a little bit. Anyway, I came up with a nice design, made some good foam, and did similar to what these guys are doing. In a moment, and I'll show you how some of my results were. Here's an early clip. You can ignore the front bucket. The foam is being generated in the back bucket. I quickly abandoned the household stuff, the Dawn dish detergent, and I went right away to the Drexel foam marker 160. This is what you get from the local farm store. Farmers use it to apply pesticides and things like that. Although it is made for farmers, you can look up videos with this search term and you almost always get Aircrete videos. I figured the farm equipment to generate this foam would be also cheaper than the construction equipment version of it, and it is. You can look into that. But first, I wanted to build myself a homemade version. So my father actually ended up building this one with a fuel pump and some other bits. I improved it a little bit by swapping out the chains and steel wool that were in that gun with shower scrubby loofah things. I did this to avoid the rust problem that Harry had, but it also made better foam. Here the plan is to fill up this bucket, and then weigh it, and then calculate the foam density. So first we're going to fill it all the way to the top. Maybe put a little extra there just to, account for some gaps on the side. A little bit more. So this first bucket was 2 pounds, 14 ounces, and 5 gallons of water weighs over 40 pounds. So this is about 7% of that weight.
Could I touch it?
Yeah, put your hand in just to see how it flows.
Oh, that's so cool.
To speed things up, I redid the foam gun to get rid of that slow fuel pump that was causing the problems before. And I just connected the air compressor to the top of the tank tube, that big one on the diagonal there. And then that Drexel mixture flows down to the gun. And then the back of the gun is also connected to the air compressor to give it that final push. The gun is filled with loofahs that turbulently mix the air and soapy water, and the bubbles come out the bottom. So this makes about 6 pounds, so more than double the last one. I just need to adjust the flow rates of the two tubes until I get what I wanted. Phase 2 is mixing the foam with the cement, basically using it instead of the water and aggregates. Just a small scoop of cement to make a whole bucket of Aircrete. While mixing, I try to use the mixer to add air, like making fluffy scrambled eggs. Tilt it like that. This first one is a dense foam that comes in at 2 pounds, 10.9 ounces. Regular concrete would weigh about 7 pounds for this 80 cubic inches, so this is 70% air. Here's a cross section. It looks decent with lots of uniform small bubbles. Here's another test block that had much larger bubbles. It only weighed about half a pound, so 93% air. A lot of the other lower density blocks collapsed a bit. This one collapsed almost completely, and this one also. So a random fraction of the blocks I poured just collapsed like that. Some worked, some didn't. Here's an example of a bucket collapsing before I even pour it into the pan. unacceptable for lightweight fill. I can't have this risk. Going back to YouTube, we'll find lots of people are discovering the same thing. You see all these trays on this table, those are all different test cases. Some of them collapsed, some of them didn't. From the same batch, it's not very predictable. You see Aircrete Harry suffers from this problem, lots of others suffer from this problem. You see these two bowls in this thumbnail, the back bowl is collapsed, the front bowl is good. So Aircrete collapsing time lapse is what this video is called. So you see lots of things like this out there. By now my foam was pretty awesome, so I didn't think the solution was to buy an expensive foam generator. The problem is that the bubbles are just not very reliable. I happen to have a lot of polystyrene scraps left over from deliveries and that sort of thing, Amazon packages and so on. These polystyrene bubbles will not collapse like air bubbles. So I made myself a polystyrene shredder, and that worked very nicely. Here Michael is taxed with turning our EPS scraps into little pellets that we can mix into the concrete. Actually, I think my father made most of this machine also. Don't worry about his fingers, it's much safer than these videos make it appear. I'd run it for a good while myself before letting the kids near it, and then I made sure he knew what he was doing before I turned on the camera and started recording. But it's basically a 2-inch PVC with a bunch of screws drilled into it. And that thing spins and it just rips the stuff up and down into a bag. This mix process is so reliable now with no chance of collapse. So anyone can mix up a batch. Here's my other son David mixing up a batch with EPS as the aggregate. And so 1 pound, 7.2 ounces, or 658 grams for my European friends, about 79% reduction in density compared to concrete. So that means it's not super light, but it's light enough to float. So here we'll float it. Yeah, there we go. Lots of polystyrene in that cross section, and lots of little air voids also. Here's a Aircrete, and that also floats as you would expect. About the same. Here's that lower density Aircrete from that first sample. It also floats, but just barely, which means it's less dense than water, which is less than half as dense as concrete. So this is about 42% of the weight of the concrete. So you can kind of get an idea of how these kind of bob around. What about fire? This is a basic map gas torch. They burn very hot. This one claims to burn at 3,750 degrees Fahrenheit. But even a basic match would melt this polystyrene. You just don't want to breathe it in. So, but what about when it is encased in concrete, when the polystyrene bubbles are encased in concrete? So let's try that. Inside the concrete. So the styrofoam all instantly melted. It wouldn't say it burned. This sort of got vaporized but left all the holes. And now everything below that is protected.
So the walls are fireproof to a degree. Fire resistant.
So I think this is going to work well. We're going to go ahead with this EPS-Crete and go for that. Let's get back to the build. It's all about the layers, and this roof section already has several layers of waterproofing, but I need to add another one. And you always want to tuck these things under the other layers, so it has to go up now before that wall goes in. So this is 45 mil EPDM rubber roof membrane. I patch it with some special rubber glue that stays waterproof so that all these little overlaps can be nice and sealed. And then we'll put the first layer of insulation over the top of it. You may have noticed that this is an unusual way to build. Yeah, I get that. If you want to tell me in the comment section, that's fine. All the engagement feeds the algorithm, but yes, I'm well aware. The basic structure of this part of the wall is treated 2x4s that hold the shape, and then the insulation and lath are attached with triple coated screws to the outside. And this leaves about a 6-inch wall void that I'm going to try to fill with this EPS-Crete. It's lightweight, so it doesn't put a lot of load on that roof section. Why 2 layers, white and pink? Well, the white sheets of EPS were almost free to me, but they crumble easily and absorb water and have other issues. The pink XPS sheets are more expensive. I had to buy those, but they're also much more robust, and the closed cell chemistry of them makes them waterproof. So I usually only use the white stuff when it's protected by a layer of pink stuff. Those crossboards are really there as attachment points for the screws holding the lath on the inside of the wall. Looking down from the top, those screws and those sideboards give the EPS-Crete something to hold on to. You'll see when I pack it in that I used a denser mixture with meaning less EPS on the sides that grab those. But you can also see the EPS isn't really pourable. I can't just build the form and pour the wall from the top. Instead, I'm building short sections of the forms with the insulation, then I hand pack it with EPS-Crete, and then I add more insulation in stages, just going up bit by bit. Here on the left there, you can see the thicker stuff, and then I put the thinner stuff in between. The next step is to form a bond beam, or bond ring, I guess, around the top of the wall all the way around. Two parallel boards form the shape of it, and then I'll pour concrete in there. These top blocks that I'm screwing in prevent the form from spreading when the pressure's in there, but they're also going to be anchor points for the roof trusses that will sit on top of this. And then I start filling with concrete. I actually put some EPS-Crete in the middle of the beam first, and I filled up the top of the lower blocks, and then it gave me something to put the rebar sitting on top of. And there I added the rebar. I put it right on top of the EPS little mound there. And then I start adding proper concrete. Concrete with glass fibers, stone aggregate, that sort of thing. It forms the top of that concrete bond beam. It's a bond ring, really, that will tie this whole top of this wall together. This needs to be one solid piece of concrete all the way around, all poured at once. Poured in quotes. We can't just stop at dusk. We've got to keep going. Bucket by bucket by bucket. I guess where the buckets are coming from? Sherry and the boys are mixing down on the ground, and then the boys are running the buckets up to me. I really don't think I could have completed this by myself. It would have been too exhausting. And now I'm doing the trowel work by flashlight just to finish up the surface of the bond beam. And the tower walls are done. Thank you very much for watching. See you on the next one.